Alright, in this video I'm going to show the shatter meshes that I've implemented in the game. And first we'll start on the Maya side to show how everything's set up. So here we have the skeleton warrior, and essentially I just talk with the artists and we split along certain lines. So there's about 14 pieces that make up the character. Here's the pelvis that's been split, the upper and the lower legs. Here's the helmet and the skull. So essentially the artist just chops up the original mesh, and if I show it here, so this is the mesh with the player that's been skinned. So you've seen this before. And then what I do is I take these individual pieces, for example this, and I position it based on the bones of the skeleton hierarchy. So it doesn't matter how the character is animating, there won't be a pop when I substitute the skinned mesh for this mesh that's composed of just separate pieces of the character. It'll be pretty seamless, and you won't see any difference when I do the switch. And eventually what I do is I just separate the pieces that I want to shatter. So here's the chest armor for the skeleton. That's one piece. And here would be the pelvis. So these are separate pieces that aren't skinned to the skeleton. I just position them using the joints of the skeleton for the character. And here you can see the helmet, the arm. Of course, when we chop it, we close off certain pieces so there's no holes or gaps. And let's see, the boot with his kneecap. Again, we close off the mesh so you don't see any holes. And the skull. So next I'll show this script that I created to use to position everything for the character, like how I did that. So essentially it's a script that designates, say for the upper arm, that I'm going to use this joint. And one of the things I did in the script is the characters create the joints in order to animate the character as efficiently as possible. So they don't really create joints to position separate objects on the skeleton. That's not the goal of the skeleton. So what I did is I did a little bit of scripting on my end to finagle these joints and to either offset or orient them in a way that it'll help out the placing of my shatter meshes so that it looks pretty seamless. And in some cases I just procedurally generate the orientations. For instance, anything below the legs, or at least below the pelvis, I had to generate my own orientation and position matrix in order to orient these joints, because the joints they created weren't helping me position the shatter meshes in all circumstances. So I'll show how I do that in the next portion of the video. And of course I'll show the part that everyone wants to see, the shatter mesh in action in the game. So that'll be in the second part of this video. Okay, now I'll show the script that I used to put all these shatter meshes together. And as before, I use an entity component system architecture to set this up. So there's a shatter mesh, which uses the same C-game entity base class as, for example, the overlord or the player or the enemy knights. And the way I change everything is I just use a component. And in this case, it's a shatter mesh component. And here's where I do all the scripting to set everything up. So if we check here, here's the chest mesh that I'd shown earlier. So here's how you sync it up. There's some parameters to control the velocity, to mess around with gravity, and to calculate rotations of the mesh as it jumps around, collision boxes. And here's the important part right here, which I use to position these meshes when I do the model swap, so that there'll be no pops, and this chest mesh will be perfectly positioned, or as close as possible to the animation that's currently playing on the enemy knight that's going to shatter. So for this, here's what I used for the position, so we're going to use the chest joint. Now, since both, I have two joints that I can use for positioning, and since they're both the same, in that case, I'm going to just go into the skeleton, find the chest joint, and use its world space position because it's okay to use. Sometimes if the joints differ, what it'll do is it'll take the midpoint of those two joints to calculate the position. And then this is what I call the finagling factor. So if you're not happy with that position perfectly, you can do a little bit of nudging or offsetting from that joint to get it just right. And then I use the orientation. So here I have the what I'm going to use as the up axis, and again I'm using the chest joint for the up axis. And if it differs, in that case I'll calculate my own up axis and I'll generate the orientation on the fly. Sometimes I have to do that because for whatever reason the joints that the artist has set up, they're not helping me. So then I just procedurally generate the orientation for the shatter mesh. So as you can see, there's a lot of finagling and figuring things out. And also for the up axis, you may be wondering, why is X the up axis? Shouldn't it be Y? And what's happening there is the artists, they orient their joints however they feel like it. And so it's not something that they're orienting to help me out. So here I'm just saying, when you get the chest joint, you're going to use the x-axis as the up axis, and the same over here when I'm using the look axis, we're going to use the y, and for the side axis you'd normally use x, but for whatever reason when I inspected that in the skeleton, it was the z axis, so that's what I used to build up the orientation. And in this case, like I said, I'm using the actual joints from the skeleton. I'm just moving things around behind the scenes. And again, another finagling factor. If I don't like the orientation, I can fool around and offset, like based on the X, Y, and Z for the rotation. I can just nudge it a little bit to make it look a little bit better. And I'll try and find one where things aren't, well, this one's the same. It's using pelvis. Let me see if I look down. But as you can see, I'm going through and creating shatter meshes for each portion. So here's the head. And again, I think it's at the bottom. The helmet, another one. Let me see. I'll find something. Well, here's one where I'm using an offset. So here I'm using the armor R joint. And again, in this case, it's the Z axis for the up axis. So again, it changes based on whatever joint I use. I have to analyze the model or the skeleton and figure out what I want to do. And here again, it's the look axis. But here again, I want to grab the y-axis and use it as the look axis, but I want to negate it. So like I said, it's a lot of looking at the model and seeing what I can use. And again, even after doing all this, I don't like the way it's oriented. So here what I'm doing is I'm adding some angles. So on the, what would this be? The x-axis for the orientation, I want to shift it -10 degrees. And on the z-axis, I want to shift -20 degrees. So like I said, even after I set all this up for the orientation, I still finagle a little bit for some of the orientations. And you may be wondering, how did I get these values? It's just trial and error until I see what I like. I just set this up. I shoot my projectile to shatter the mesh. Then I see the model swap. And what I do is I record it, and then I step frame by frame to make sure that it looks okay. And if I don't like it exactly, I just put in some values until I shift it and I say, it looks more or less okay. Because that's the other thing. These meshes are rigid. They're not skinned to the skeleton. So even after I do the replacing and I set everything properly, there's still going to be a very slight pop because the other mesh is being skinned and deformed by the skeleton. And this is just a rigid mesh that's not part of the skeleton. But I do what I can to get it close enough. And when I show the video of it in action, you'll see that it's pretty seamless. And it's hard to tell if there's any pop. But I'll find one where I generated everything procedurally, if I can. Lower arm. I think it was the legs. Let me see. Ah, yeah, here we go. So here, see how the joints differ? I'm using our ankle and our knee. Here what happened is I just couldn't find the joint that that would work for positioning the lower legs. So I picked two joints. So in this case, it'll get the position of the first joint and the second joint, and the midpoint is what I'll use for the position. And the same for the up axis. As soon as these joints vary for the up axis, I generate my own up axis based on the positions of these joints, and then from that I procedurally generate the orientation. So here I don't use the joints, I generate it myself, and I just had to do that. So actually I should probably remove this because it won't be used. As soon as it encounters this, it realizes it needs to use these joints to generate the orientation procedurally. So yeah, I left that in, but it's okay. Even then, even after I generate the orientation procedurally, I still do a little bit of finagling on the x-axis just to get it looking a little bit better, or just to have more precise control. So as you can see, this is more a bit of an art and a science, and I've set up enough options in the script so that I can change parameters on the fly and then do my little inspections and then figure out what I need to do. And the mesh type I also use when I do the shatter to calculate sometimes how I want the mesh to shatter and in what direction. This is used by the component system when it's processing the shatter mesh component. It uses the mesh type to figure out the rules for what it's going to do for shattering the mesh. So here there's 14 pieces. And like I said, I describe each and every one. Luckily, once I do this for the shatter mesh for the skeleton, I can reuse this for the overlord, or not for the overlord, for that red knight that I showed earlier. All I have to do is I just change the type of mesh that we're using. So I only have to go through this once, and then it's done. It's good enough. Of course, if I add a completely different character that doesn't share the skeleton like the skeleton knight and the red knight do, then I'll probably have to do this all over again, but that's not going to happen. And as for the collision ABB that I use, I just pick some numbers. I go into Maya and I make a little box that more or less covers the different orientations for the shatter mesh as it rotates, like something that'll look good and it won't make it look, like that it'll fall through the world or it's too thin. Something that, it's an average collision box that'll make everything look good, more or less. So that's how I came up with that. I just model something in Maya and look at it and say, okay, that'll work, and then I test it in the engine. So there I pretty much show at least a little bit of the scripting that I used to hook this up all together. And part of the reason why I did this is I didn't want to do what the other games do, where they just put everything in one spot at the center of the model and then just make everything blow up. I sort of wanted a swap where you wouldn't notice that I've swapped the model and I'd wanted everything positioned at the same location as the character was animating. So if he was running with his arms, going from side to side, one leg up in the air and the other one trailing backwards, I wanted to swap out that skeleton rig and the skin mesh and put all the shatter meshes at exactly the correct position so you wouldn't see any weird transition. So that was the plan for doing this. And next I'll show the effect running in the game and explain a little bit of the technology behind it so that I can cut down on draw calls. And that'll be the next thing I show. Alright, here's the part everyone's been waiting for with the shatter meshes. So as you can see, they break apart once I shoot that little axis align bounding box, which is just a debug projectile for now. But as you can see, there's no pop, or at least it looks pretty seamless. And then I like leaving a trail of destruction, so that's part of the reason why I put this effect in. You can have fun blowing up your opponents and leaving a mess as the pieces bounce around the world. And it'll scale fairly well. Like, I can have tons of these exploding and you'll have 60 frames a second, no problem. And what I do is, I guess in Unity, this effect, it's called dynamic batching, where you build up your instances on the CPU. So what I do is those 14 pieces that shatter. Let's do some more blowing up here. The 14 pieces that shatter, I animate them individually on the CPU using assembly language. Yeah, it's still used. And then once I've animated the pieces or oriented them, which is something the video card would normally do, then I weld all those pieces into one mesh, or maybe two meshes, depending on the size of the vertex and index buffers for the instance that I want to use. And so those 14 draw calls become perhaps one draw call. So that's how I keep down on the draw calls for this. And essentially, you know, the 14 pieces, like I said, it becomes one call. Again, for this to work, the shatter meshes have to be sort of low poly counts, because you can't have a shatter mesh that's, say, 10,000 polygons. It won't work. It has to be kept down for it to work. And here I do a little effect where everything sinks down below the world after a certain time to clean it up. So I'll show it a little bit more just so we can see the effect as I try to overload it. But that's essentially the effect for shattering. The only thing I haven't shown is I'll put some particle effects, and I'll show that in a later video. But one thing is, I like the way the meshes shatter and how everything moves. And so I'm only going to put like really subtle effects for the particles that are really cool, because if I overdo it, then, you know, all these particles will be, or all the shatter meshes will be lost or hidden by the particle effects. So I'll do something subtle. But for now, I'll just show the character running around, and I'll try to stress the system so that you can see it scales fairly well. And I also, when I do these CPU instancing for the shatter meshes, I also multi-thread it so it's running on separate cores. So that's another little speed up that you can do if you want to do this yourself. But again, I'll show this running under load next. All right, now I'll just try and have as much stuff blowing up as possible. Probably if I, there you can see. So as you can see, it's scales really well. And I just like this effect. I always try to do games that involve stuff breaking up. I just like seeing stuff bounce around, especially lots of stuff like this where it's like 14 pieces. So it also shows the power of these phones, like you can actually get away with this. I'm testing this on an iPhone 5, but it'll work just as well on the iPhone 4. And I just wanted to show a really cheap effect that you can get away with without having to use, you know, like a physics engine to get it off the ground. And yeah, it's simple friction that I'm doing and really simple collision tests. So that's another reason why it'll scale really well when I do this. So there you can see. And I like seeing all this stuff on the floor. I don't know why. It's something I like seeing in games, just to see how I can blow stuff up. And also the effect will look a lot nicer when I have all the geometry in place, because then it'll be bouncing, you know, through all the obstacles, like the trains, the other characters. So that'll be another thing that'll add a little bit of fun or realism to this effect. But for now, that's one of the cool effects, at least I think so, that I have to show. And so next time I'll show the particle effects, and I'll show how subtly I do them, so that I'll still preserve the ability for you to view the shatter meshes, but I'll just add that final little touch that'll put this little gag effect, you know, over the top and have it all finished. So that's what I'll show in the next video, I hope. Or I may show another finished level chunk. We'll see. But for now, that's what I have. Thanks, and bye.